Hello everyone. Question is, a data analyst runs a large number of data manipulation language DML queries by using Amazon Athena with the JDBC driver. Recently, a query failed after it ran for 30 minutes. The query returned the following message. The data analyst does not immediately need the query results. However, the data analyst needs a long-term solution for this problem. Which solution will meet these requirements? Option A, split the query into smaller queries to search smaller subsets of data. Option B, in the settings for Athena, adjusts the DML query timeout limit. Option C, in the service quotas console, request an increase for the DML query timeout. Option B, save the tables as compressed.csv files. Correct answer is option C. Question is, a retail company is using an Amazon S3 bucket to host an e-commerce data lake. The company is using AWS Lake Formation to manage the data lake. A data analytics specialist must provide access to a new business analyst team. The team will use Amazon Athena from the AWS Management Console to query data from existing wave_sales and customer tables in the e-commerce database. The team needs read-only access and the ability to uniquely identify customers by using first and last names. However, the team must not be able to see any other personally identifiable data. The table structure is as follows. Which combination of steps should the data analytics specialist take to provide the required permission by using the principle of least privilege? Choose three options. Option A, in AWS Lake Formation, grant the business_analyst group select and alter permissions for the wave_sales table. Option B, in AWS Lake Formation, grant the business_analyst group the select permission for the wave_sales table. Option C, in AWS Lake Formation, grant the business_analyst group the select permission for the customer table. Under columns, choose filter type, include columns with columns first_name, last_name, and customer_ID. Option D, in AWS Lake Formation, grant the business_analyst group select and alter permissions for the customer table. Under columns, choose filter type, include columns with columns first_name and last_name. Option E, create users under a business_analyst IAM group. Create a policy that allows the lake formation get data access action, the Athena action, and the glue get action. Option F, create users under a business_analyst IAM group. Create a policy that allows the lake formation get data access action, the Athena action, and the glue get action. In addition, allow the S3 get object action, the S3 put object action, and the S3 get bucket location action for the Athena query results S3 bucket. Correct answer is option B, D, and option F. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company has multiple data workflows to ingest data from its operational databases into its data lake on Amazon S3. The workflows use AWS Glue and Amazon EMR for data processing and ETL. The company wants to enhance its architecture to provide automated orchestration and minimize manual intervention. Which solution should the company use to manage the data workflows to meet these requirements? Option A, AWS Glue Workflows. Option B, AWS Step Functions. Option C, AWS Lambda. Option D, AWS Batch. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, an online retail company is using Amazon Redshift to run queries and perform analytics on customer shopping behavior. When multiple queries are running on the cluster, runtime for small queries increases significantly. The company's data analytics team to decrease the runtime of these small queries by prioritizing them ahead of large queries. Which solution will meet these requirements? Option A, use Amazon Redshift Spectrum for small queries. Option B, increase the concurrency limit in workload management WLM. Option C, configure short query acceleration in workload management WLM. Option D, add a dedicated compute node for small queries. Correct answer is option C. Question is, a company uses Amazon Redshift as its data warehouse. A new table includes some columns that contain sensitive data and some columns that contains non-sensitive data. The data in the table eventually will be referenced by several existing queries that run many times each day. A data analytics specialist must ensure that only members of the company's auditing team can read the columns that contain sensitive data. All other users must have read-only access to the columns that contain non-sensitive data. Which solution will meet these requirements with the least operational overhead? Option A grants the auditing team permission to read from the table. Load the columns that contain non-sensitive data into a second table. Grant the appropriate users read-only permissions to the second table. Option B, grant all users read-only permissions to the columns that contain non-sensitive data. Use the grant select command to allow the auditing team to access the columns that contain sensitive data. Option C, grant all users read-only permissions to the columns that contain non-sensitive data. Attach an IAM policy to the auditing team with an explicit allow action that grants access to the columns that contain sensitive data. Option D, grant the auditing team permission to read from the table. Create a view of the table that includes the columns that contain non-sensitive data. Grant the appropriate users read-only permissions to that view. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company hosts an Apache Flink application on premises. The application processes data from several Apache Kafka clusters. The data originates from a variety of sources such as web applications, mobile apps, and operational databases. The company has migrated some of these sources to AWS and now wants to migrate the Flink application. The company must ensure that Data that resides in databases within the VPC does not traverse the Internet. The application must be able to process all the data that comes from the company's AWS solution, on-premises resources, and the public Internet. Which solution will meet these requirements with the least operational overhead? Option A. Implement Flink on Amazon EC2 within the company's VPC. Create Amazon Managed Streaming for Apache Kafka, that is Amazon MSK clusters in the VPC to collect data that comes from the applications and databases within the VPC. Use Amazon Kinesis data streams to collect data that comes from the public Internet. Configure Flink to have sources from Kinesis data streams, Amazon MSK, and any on-premises Kafka clusters by using AWS Client VPN or AWS Direct Connect. Option B. Implement Flink on Amazon EC2 within the company's VPC. Use Amazon Kinesis data streams to collect data that comes from the applications and databases within the VPC and the public Internet. Configure Flink to have sources from Kinesis data streams and any on-premises Kafka clusters by using AWS Client VPN or AWS Direct Connect. Option C. Create an Amazon Kinesis data analytics application by uploading the compiled Flink.jar file. Use Amazon Kinesis data streams to collect data that comes from applications and databases within the VPC and the public Internet. Configure the Kinesis data analytics application to have sources from Kinesis data streams and any on-premises Kafka clusters by using AWS Client VPN or AWS Direct Connect. Option D. Create an Amazon Kinesis data analytics application by uploading the compiled Flink.jar file. Create Amazon Managed Streaming for Apache Kafka, that is Amazon MSK clusters in the company's VPC to collect data that comes from the applications and databases within the VPC. Use Amazon Kinesis data streams to collect data that comes from the public Internet. Configure the Kinesis data analytics application to have sources from Kinesis data streams, Amazon MSK, and any on-premises Kafka clusters by using AWS Client VPN or AWS Direct Connect. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a technology company has an application with millions of active users every day. The company queries daily users data with Amazon Athena to understand how users interact with the application. The data includes the date and time, the location ID, and the service used. The company wants to use Athena to run queries to analyze the data with the lowest latency possible. Which solution meets these requirements? Option A. Store the data in Apache Avro format with the date and time as the partition with the data sorted by the location ID. Option B. Store the data in Apache Parquet format with the date and time as the partition with the data sorted by the location ID. Option C. Store the data in Apache ORC format with the location ID as the partition with the data sorted by the date and time. Option D. Store the data in .csv format with the location ID as the partition with the data sorted by the date and time. Correct answer is option C. Question is, a real estate company maintains data about all properties listed in a market. The company receives data about new property listings from vendors who upload the data daily as compressed files into Amazon S3. The company's leadership team wants to see the most up-to-date listings as soon as the data is uploaded to Amazon S3. The data analytics team must automate and orchestrate the data processing workflow of the listings to feed a dashboard. The team also must provide the ability to perform one-time queries and analytical reporting in a scalable manner. Which solution meets these requirements most cost effectively? Option A, use Amazon EMR for processing incoming data. Use AWS step functions for workflow orchestration. Use Apache Hive for one-time queries and analytical reporting. Bulk ingest in data in Amazon OpenSearch service, that is Amazon Elasticsearch service. Use OpenSearch dashboards Kibana on Amazon OpenSearch service, that is Amazon Elasticsearch service for the dashboard. Option B, use Amazon EMR for processing incoming data. Use AWS step functions for workflow orchestration. Use Amazon Athena for one-time queries and analytical reporting. Use Amazon QuickSight for the dashboard. Option C, use AWS Glue for processing incoming data. Use AWS step functions for workflow orchestration. Use Amazon Redshift Spectrum for one-time queries and analytical reporting. Use OpenSearch dashboards Kibana on Amazon OpenSearch service, that is Amazon Elasticsearch service for the dashboard. Option D, use AWS Glue for processing incoming data. Use AWS Lambda and S3 event notifications for workflow orchestration. Use Amazon Athena for one-time queries and analytical reporting. Use Amazon QuickSight for the dashboard. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a marketing company collects data from third-party providers and uses transient Amazon EMR clusters to process this data. The company wants to host an Apache Hive metastore that is persistent, reliable, and can be accessed by EMR clusters and multiple AWS services and accounts simultaneously. The metastore must also be available at all times. Which solution meets these requirements with the least operational overhead? Option A, use AWS Glue Data Catalog as the metastore. Option B, use an external Amazon EC2 instance running MySQL as the metastore. Option C, use Amazon RDS for MySQL as the metastore. Option D, use Amazon S3 as the metastore. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a data engineer is using AWS Glue ETL jobs to process data at frequent intervals. The processed data is then copied into Amazon S3. The ETL jobs run every 15 minutes. The AWS Glue data catalog partitions need to be updated automatically after the completion of each job. Which solution will meet these requirements most cost effectively? Option A, use the AWS Glue data catalog to manage the data catalog. Define an AWS Glue workflow for the ETL process. Define a trigger within the workflow that can start the crawler when an ETL job run is complete. Option B. Use the AWS Glue Data Catalog to manage the data catalog. Use AWS Glue Studio to manage ETL jobs. Use the AWS Glue Studio feature that supports updates to the AWS Glue Data Catalog during job runs. Option C. Use an Apache Hive Metastore to manage the data catalog. Update the AWS Glue ETL code to include the enable update catalog and partition keys arguments. Option D. Use the AWS Glue Data Catalog to manage the data catalog. Update the AWS Glue ETL code to include the enable update catalog and partition key arguments. Correct answer is option A. Question is, a reseller that has thousands of AWS accounts receives AWS cost and uses reports in an Amazon S3 bucket. The reports are delivered to the S3 bucket in the following format. An AWS Glue crawler crawls the S3 bucket and populates an AWS Glue data catalog with a table. Business analysts use Amazon Athena to query the table and create monthly summary reports for the AWS accounts. The business analysts are experiencing slow queries because of the accumulation of reports from the last 5 years. The business analyst wants the operations team to make changes to the improve query performance. Which actions should the operations team take to meet these requirements? Option A. Change the file format to .csv.zip. Option B. Partition the data by date and account ID. Option C. Partition the data by month and account ID. Option D. Partition the data by account ID, year and month. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company using Amazon QuickSight Enterprise Edition has thousands of dashboards, analysis, and data sets. The company struggles to manage and assign permissions for granting users access to various items within QuickSight. The company wants to make it easier to implement sharing and permissions management. Which solution should the company implement to simplify permissions management? Option A. Use QuickSight folders to organize dashboards, analysis, and data sets. Assign individual users permissions to these folders. Option B. Use QuickSight folders to organize dashboards, analysis, and data sets. Assign group permissions by using these folders. Option C. Use AWS IAM resource-based policies to assign group permissions to QuickSight items. Option D. Use QuickSight user management APIs to provision group permissions based on dashboard naming conventions. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company has 10 to 15 TB of uncompressed .csv files in Amazon S3. The company is evaluating Amazon Athena as one-time query engine. The company wants to transform the data to optimize query runtime and storage costs. Which option for data format and compression meets these requirements? Option A. CSV compressed with zip. Option B. JSON compressed with B. Zip2. Option C. Apache Paraquat compressed with Snappy. Option D. Apache Avro compressed with LZO. Correct answer is option B. Question is, a company uses Amazon Redshift to store its data. The reporting team runs ad hoc queries to generate reports from the Amazon Redshift database. The reporting team recently started to experience inconsistencies in report generation. Ad hoc queries used to generate reports that would typically take minutes to run can take hours to run. A data analytics specialist debugging the issue finds that ad hoc queries are stuck in the queue behind long-running queries. How should the data analytics specialist resolve the issue? Option A. Create partitions in the tables queried in ad hoc queries. Option B. Configure automatic workload management (WLM) from the Amazon Redshift console. Option C. Create Amazon Simple Queue Service Amazon SQS queues with the different priorities. Assign queries to queue based on priority. Option D. Run the vacuum command for all tables in the database. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company provides an incentive to users who are physically active. The company wants to determine how active the users are by using an application on their mobile devices to track the number of steps they take each day. The company needs to ingest and perform near real-time analytics on live data. The processed data must be stored and must remain available for 1 year for analytics purposes. Which solution will meet these requirements with the least operational overhead? Option A. Use Amazon Cognito to write the data from the application to Amazon DynamoDB. Use an AWS step functions workflow to create a transient Amazon EMR cluster every hour and process the new data from DynamoDB. Output the processed data to Amazon Redshift for analytics. Archive the data from Amazon Redshift after 1 year. Option B. Ingest the data into Amazon DynamoDB by using an Amazon API gateway API as a DynamoDB proxy. Use an AWS step functions workflow to create a transient Amazon EMR cluster every hour and process the new data from DynamoDB. Output the processed data to Amazon Redshift to run analytics calculations. Archive the data from Amazon Redshift after 1 year. Option C. Ingest the data into Amazon Kinesis data streams by using an Amazon API gateway API as a Kinesis proxy. Run Amazon Kinesis data analytics on the stream data. Output the processed data into Amazon S3 by using Amazon Kinesis data firehose. Use Amazon Athena to run analytics calculations. Use S3 lifecycle rules to transition objects to S3 Glacier after 1 year. Option D. Write the data from the application into Amazon S3 by using Amazon Kinesis data firehose. Use Amazon Athena to run the analytics on the data in Amazon S3. Use S3 lifecycle rules to transition objects to S3 Glacier after 1 year. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is a financial company hosts a data lake in Amazon S3 and a data warehouse on an Amazon Redshift cluster. The company uses Amazon QuickSight to build dashboards and wants to secure access from its on-premises Active Directory to Amazon QuickSight. How should the data be secured? Option A. Use an Active Directory connector and single sign-on SSO in a corporate network environment. Option B. Use a VPC endpoint to connect to Amazon S3 from Amazon QuickSight and an IAM role to authenticate Amazon Redshift. Option C. Establish a secure connection by creating an S3 endpoint to connect Amazon QuickSight and a VPC endpoint to connect to Amazon Redshift. Option D. Place Amazon QuickSight and Amazon Redshift in the security group and use an Amazon S3 endpoint to connect Amazon QuickSight to Amazon S3. Correct answer is option B. Question is a data analyst is using AWS Glue to organize, cleanse, validate, and format a 200 GB data set. The data analyst triggered the job to run with the standard worker type. After 3 hours, the AWS Glue job status is still running. Logs from the job run show no error codes. The data analyst wants to improve the job execution time without over-provisioning. Which actions should the data analyst take? Option A. Enable job bookmarks in AWS Glue to estimate the number of data processing units DPUs. Based on the profiled metrics, increase the value of the executor code's job parameter. Option B. Enable job metrics in AWS Glue to estimate the number of data processing units DPUs. Based on the profiled metrics, increase the value of the maximum capacity job parameter. Option C. Enable job metrics in AWS Glue to estimate the number of data processing units DPUs. Based on the profiled metrics, increase the value of the spark.yarn.executor.memory overhead job parameter. Option D. Enable the job bookmarks in AWS Glue to estimate the number of data processing units DPUs. Based on the profiled metrics, increase the value of the num executor's job parameter. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a manufacturing company has been collecting IoT sensor data from the devices on its factory floor for a year and is storing the data in Amazon Redshift for daily analysis. A data analyst has determined that at an accepted ingestion rate of about 2 TB per day, the cluster will be undersized in less than 4 months. A long-term solution is needed. The data analyst has indicated that most queries only reference the most recent 13 months of data, yet there are also quarterly reports that need to query all the data generated from the past 7 years. The Chief Technology Officer (CTO) is concerned about the cost, administrative effort, and performance of a long-term solution. Which solution should the data analyst use to meet these requirements? Option A. Create a daily job in AWS Glue to unload records older than 13 months to Amazon S3 and delete those records from Amazon Redshift. Create an external table in Amazon Redshift to point to the S3 location. Use Amazon Redshift Spectrum to join the data that is older than 13 months. Option B. Take a snapshot of the Amazon Redshift cluster. Restore the cluster to take to a new cluster using dense storage nodes with additional storage capacity. Option C. Execute a create table as select CTAS statement to move records that are older than 13 months to quarterly partitioned data in Amazon Redshift Spectrum backed by Amazon S3. Option D. Unload all the tables in Amazon Redshift to an Amazon S3 bucket using S3 intelligent tiering. Using AWS, use AWS Glue to crawl the S3 bucket location to create external tables in an AWS Glue data catalog. Create an Amazon EMR cluster using auto-scaling for any daily analytics needs. And use Amazon Athena for the quarterly reports with both using the same AWS Glue data catalog. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a company analyzes its data in an Amazon Redshift data warehouse which currently has a cluster of 3 dense storage nodes. Due to a recent business acquisition, the company needs to load an additional 4 TB of user data into Amazon Redshift. The engineering team will combine all the user data and apply complex calculations that require IO-intensive resources. The company needs to adjust the cluster's capacity to support the change in analytical and storage requirements. Which solution meets these requirements? Option A. Resize the cluster using elastic resize with dense compute nodes. Option B. Resize the cluster using classic resize with dense compute nodes. Option C. Resize the cluster using elastic resize with dense storage nodes. Option D. Resize the cluster using classic resize with dense storage nodes. Correct answer is option C. Question is, a media company has been performing analytics on log data generated by its applications. There has been a recent increase in the number of concurrent analytics jobs running, and the overall performance of existing jobs is decreasing as the number of new jobs is increasing. The partitions data is stored in Amazon S3 one zone infrequent access S3 one zone IA, and the analytic processing is performed on Amazon EMR clusters using the EMR file system EMRFS with consistent view enabled. A data analyst has determined that it is taking longer for the EMR task nodes to the list objects in the Amazon S3. Which action would most likely increase the performance of accessing log data in Amazon S3? Option A. Use a hash function to create a random string and add that to the beginning of the object prefixes when storing the log data in Amazon S3. Option B. Use a lifecycle policy to change the S3 storage class to S3 standard for the log data. Option C. Increase the read capacity unit RCUs for the shared Amazon DynamoDB table. Option D. Redeploy the EMR clusters that are running slowly to a different availability zone. Correct answer is option D. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company that monitors weather conditions from remote construction sites is setting up a solution to collect temperature data from the following 2 weather stations. First, station A, which has 10 census Second, Station B, which has 5 sensors. These weather stations were placed by on-site subject matter experts. Each sensor has a unique ID. The data collected from each sensor will be collected using Amazon Kinesis data streams. Based on the total incoming and outgoing data throughput, a single Amazon Kinesis data stream with two sorts is created. Two partition keys are created based on the station names. During testing, there is a bottleneck on the data coming from station A but not from station B. Upon review, it is confirmed that the total stream throughput is still less than the allocated Kinesis data streams throughput. How can this bottleneck be resolved without increasing the overall cost and complexity of the solution, while retaining the data collection quality requirements? Option A. Increase the number of shards in Kinesis data streams to increase the level of parallelism. Option B. Create a separate Kinesis data stream for Station A with two shards and stream Station A sensor data to the new stream. Option C. Modify the partition key to use the sensor ID instead of the station name. Option D. Reduce the number of sensors in Station A from 10 to 5 sensors. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a mobile gaming company wants to capture data from its gaming app and make the data available for analysis immediately. The data record size will be approximately 20 KB. The company is concerned about the achieving optimal throughput from each device. Additionally, the company wants to develop a data stream processing application with dedicated throughput for each consumer. Which solution will achieve this goal? Option A. Have the app call the Put Records API to send data to Amazon Kinesis data streams. Use the enhanced fan-out feature while consuming the data. Option B. Have the app call the Put Record Batch API to send data to Amazon Kinesis data firehose. Submit a support case to enable dedicated throughput on the account. Option C. Have the app use Amazon Kinesis Producer Library KPL to send data to Kinesis data firehose. Use the enhanced fan-out feature while consuming the data. Option D. Have the app call the Put Records API to send data to Amazon Kinesis data streams. Host the stream processing application on the Amazon EC2 with auto scaling. Correct answer is option D. Question is, a large financial company is running its ETL process. Part of this process is to move data from Amazon S3 into an Amazon Redshift cluster. The company wants to use the most cost-efficient method to load the dataset into Amazon Redshift. Which combination of steps would meet these requirements? Choose two options. Option A. Use the copy command with the manifest file to load data into Amazon Redshift. Option B. Use S3 distcp to load files into Amazon Redshift. Option C. Use temporary staging tables during the loading process. Option D. Use the unload command to upload data into Amazon Redshift. Option E. Use Amazon Redshift Spectrum to query files from Amazon S3. Correct answer is option C and option E. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company wants to enrich application logs in near real time and use the enriched dataset for further analysis. The application is running on Amazon EC2 instances across multiple availability zones and storing its logs using Amazon CloudWatch logs. The enrichment source is stored in an Amazon DynamoDB table. Which solution meets the requirements for the event collection and enrichment? Option A. Use a CloudWatch logs subscription to send the data to Amazon Kinesis data firehose. Use AWS Lambda to transform the data in Kinesis data firehose delivery stream and enrich it with the data in the DynamoDB table. Configure Amazon S3 as the Kinesis data firehose delivery destination. Option B. Export the raw logs to Amazon S3 on an hourly basis using the AWS CLI. Use AWS Glue crawlers to catalog the logs. Set up an AWS Glue connection for the DynamoDB table and set up an AWS Glue ETL job to enrich the data. Store the enriched data in Amazon S3. Option C. Configure the application to write the logs locally and use Amazon Kinesis agent to send the data to Amazon Kinesis data streams. Configure a Kinesis Data Analytics SQL application with the Kinesis data streams as the source. Join the SQL application input stream with DynamoDB records and then store the enriched output stream in Amazon S3 using Amazon Kinesis data firehose. Option D. Export the raw logs to Amazon S3 on an hourly basis using the AWS CLI. Use Apache Spark SQL on Amazon EMR to read the logs from Amazon S3 and enrich the records with the data from DynamoDB. Store the enriched data in Amazon S3. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a marketing company is using Amazon EMR clusters for its workloads. The company manually installs third-party libraries on the clusters by logging into the master nodes. A data analyst needs to create an automated solution to replace the manual process. Which options can fulfill these requirements? Choose two options. Option A. Place the required installation scripts in Amazon S3 and execute them using custom bootstrap actions. Option B. Place the required installation scripts in Amazon S3 and execute them through Apache Spark in Amazon EMR. Option C. Install the required third-party libraries in the existing EMR master node. Create an AMI out of that master node and use that custom AMI to recreate the EMR cluster. Option D. Use an Amazon DynamoDB table to store the list of required applications. Trigger an AWS Lambda function with DynamoDB streams to install the software. Option E. Launch an Amazon EC2 instance with Amazon Linux and install the required third-party libraries on the instance. Create an AMI and use that AMI to create the EMR cluster. Correct answer is option A and option C. Question is, a marketing company is storing its campaign response data in Amazon S3. A consistent set of sources has generated the data for each campaign. The data is saved into Amazon S3 as .csv files. A business analyst will use Amazon Athena to analyze each campaign's data. The company needs the cost of ongoing data analysis with Athena to be minimized. Which combination of actions should a data analytics specialist take to meet these requirements? Choose two options. Option A, convert the .csv files to Apache Paraquet. Option B, convert the .csv files to Apache Avro. Option C, partition the data by campaign. Option D, partition the data by source. Option E, compress the .csv files. Correct answer is option B and option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a central government organization is collecting events from various internal applications using Amazon Managed Streaming per Apache Kafka Amazon MSK. The organization has configured a separate Kafka topic for each application to separate the data. For security reasons, the Kafka cluster has been configured to only allow TLS encrypted data and it encrypts the data at rest. A recent application update showed that one of the applications was configured incorrectly, resulting in writing data to a Kafka topic that belongs to another application. This resulted in multiple errors in the analytics pipeline as data from different applications appeared on the same topic. After this incident, the organization wants to prevent applications from writing to a topic different than the one they should write to. Which solution meets these requirements with the least amount of effort? Option A, create a different Amazon EC2 security group for each application. Configure each security group to have access to a specific topic in Amazon MSK cluster. Attach the security group to each application based on the topic that the applications should read and write to. Option B, install Kafka Connect on each application instance and configure each Kafka Connect instance to write to a specific topic only. Option C, use Kafka ACLs and configure read and write permissions for each topic. Use the distinguished name of the client's TLS certificates as the principal of the ACL. Option D, create a different Amazon EC2 security group for each application. Create an Amazon MSK cluster and Kafka topic for each application. Configure each security group to have access to the specific cluster. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Hello everyone. Question is, a marketing company has data in Salesforce, MySQL and Amazon S3. The company wants to use data from these three locations and create mobile dashboards for its users. The company is unsure how it should create the dashboards and needs a solution with the least possible customization and coding. Which solution meets these requirements? Option A, use Amazon Athena federated queries to join the data sources. Use Amazon QuickSight to generate the mobile dashboards. Option B, use AWS Lake Formation to migrate the data sources into Amazon S3. Use Amazon QuickSight to generate the mobile dashboards. Option C, use Amazon Redshift federated queries to join the data sources. Use Amazon QuickSight to generate the mobile dashboards. Option D, use Amazon QuickSight to connect to the data sources and generate the mobile dashboards. Correct answer is option C. Question is, a company receives data from its vendor in JSON format with a timestamp in the file name. The vendor uploads the data to an Amazon S3 bucket and the data is registered into the company's data lake for analysis and reporting. The company has configured an S3 lifecycle policy to archive all files to S3 Glacier after 5 days. The company wants to ensure that its AWS Glue crawler catalogs data only from S3 standard storage and ignores the archived files. A data analytics specialist must implement a solution to achieve this goal without changing the current S3 bucket configuration. Which solution meets these requirements? Option A. Use the exclude patterns feature of AWS Glue to identify the S3 Glacier files for the crawler to exclude. Option B. Schedule an automation job that uses AWS Lambda to move files from the original S3 bucket to a new S3 bucket for S3 Glacier storage. Option C. Use the exclude storage classes property in the AWS Glue data catalog table to exclude files on S3 Glacier storage. Option D. Use the include patterns feature of AWS Glue to identify the S3 standard files for the crawler to include. Correct answer is option A. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a hospital is building a research data lake to ingest data from electronic health records EHR systems from multiple hospitals and clinics. The EHR systems are independent of each other and do not have a common patient identifier. The data engineering team is not experienced in machine learning (ML) and has been asked to generate a unique patient identifier for the ingested records. Which solution will accomplish this task? Option A. An AWS Glue ETL job with the find matches transform. Option B. Amazon Kendra. Option C. Amazon SageMaker Ground Truth. Option D. An AWS Glue ETL job with the resolve choice transform. Correct answer is option A. Question is, a wave retail company wants to implement a near real-time clickstream analytics solution. The company wants to analyze the data with an open source package. The analytics applications will process the raw data only once, but other applications will need immediate access to the raw data for up to 1 year. Which solution meets these requirements with the least amount of the operational effort? Option A. Use Amazon Kinesis data streams to collect the data. Use Amazon EMR with the Apache Flink to consume and process the data from the Kinesis data stream. Set the retention period of the Kinesis data stream to 8.760 hours. Option B. Use Amazon Kinesis data streams to collect the data. Use Amazon Kinesis data analytics with Apache Flink to process the data in real time. Set the retention period of the Kinesis data stream to 8760 hours. Option C. Use Amazon Managed Streaming for Apache Kafka, that is Amazon MSK, to collect the data. Use Amazon EMR with the Apache Flink to consume and process the data from the Amazon MSK stream. Set the log retention hours to 8760. Option D. Use Amazon Kinesis data streams to collect the data. Use Amazon EMR with Apache Flink to consume and process the data from the Kinesis data stream. Create an Amazon Kinesis data firehose delivery stream to store the data in Amazon S3. Set an S3 lifecycle policy to delete the data after 365 days. Correct answer is option B. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe.